So 2.3 is solving systems of equations. That is finding the point that the two lines cross, intersection point. We're going to do two types, substitution and elimination. And you get to choose which type you want for whatever the question is. You don't have to do it one or the other, okay? But I'm going to show you two different ways you can solve. Me personally, if I had to solve a system, I kind of look at it and say, oh, it'd be easier like this or easier like that. I usually do elimination most times, but sometimes if it's really easy to solve using substitution, I'll do that. So I'll show you both ways and sort of when to use each one, but you can decide if you want to stick with one type and just do that only, you can do that. But before, so a system of equations, remember, is two equations or more. But we're only going to look at two. Okay, so two equations, and we're looking for the point that works in both of them. Okay, so this is called a system. We'll solve it in a minute. And the solution is a point or ordered pair that works in both. And we did it the other day by graphing, and we sort of guessed what point would work. That's not a good method to solve, because your graph isn't always accurate, but it is a method. If you had a graphing calculator, you can actually move the cursor to be right on where they cross, and you can look at it. So that works, but it's not the best way. Now, two lines with different slopes cross at one point, so they can have what we would call in math one unique solution, which just means one solution, okay? So one solution works. That would be if two lines crossed. What other types of lines could we have? Parallel lines. And what would we say for those? No solution. Now, I can, let's go back to our equation like this. Okay. Because we can think about the solutions for that really easily, right? 2 and 2, 3 and 1, 5 and negative 1. We talked about that before. I'm going to add another equation to that. Now, I actually added an equation that looks different. It's like we changed its clothes. It looks different, but it's the same. What did I do to the first equation to get the second one? I just multiplied the whole thing by 3. Multiplying both sides of an equal sign by something doesn't change it. It's still the same. It's just sort of in disguise. Like if I had the point 2, 2, that works in the first equation. Will it work in the second equation? 3 times 2 plus 3 times 2 is 6 plus 6, which is 12. It works in the second equation. What about the point 1, 3? That works in the first one. Will it work in the second one? 3 times 1 plus 3 times 3 is 3 plus 9, which is 12. That works in the second equation. I could go on forever. Because I didn't change the equation, I just changed the way it looks, but it's still the same equation. Okay, you can multiply both sides of an equal sign by a number or divide both sides by a number, and it's still the same thing. So this is a system, but the system is sort of flawed. It's like actually the same equation twice. So how many solutions does this have? This is the line x plus y equals 4. It goes through 4 and 4 here. But it's also the line 3x plus 3y equals 12. It's the same line. So this has infinitely many solutions. And that's because every point that works in the first line works in the second line, and any one line has all of these points on this graph. Remember, a line is just a series of points. All of those points work in both, so there's infinitely many that work. So you can sort of make a system that I try to disguise to look different, but then when you solve it, it is actually the same thing. So I'll show you what happens. So these are the three types of solutions. We're just going to start with the first one, and then at the end of the class, I'll just quickly show you what happens if we have one of these two cases. Okay? So we're going to start with a few systems that we solve by substitution and a few that we solve by elimination that have one solution. And most equations just have one solution. If the slope's different, then they have one. Okay, so substitution. Okay, so we're going to solve the system, find the intercepts, which we did in the earlier section, and graph both of them. So this would be how it would be on a test, something like this. Okay, so we're going to start with substitution. So I'm going to give you the equation, the two equations. So the way that these two equations are in what we call slope y-intercept form, so they're both y equals, okay? So when they're both in y equals mx plus b form, substitution is usually easier. Okay? So the way substitution works is you're plugging one into the other, but if these are both solved for y and we want them to be equal, then we just set them equal to each other. So set the equations equal. So we would have 2x plus 1 is equal to 3x minus 2. Because we want the y to be the same, so we're saying these two things, these two y values are the same, so the rest of the equation has to be the same. And then how do we solve this? Back to linear equations. Just rearrange it. I'm just putting the x's on the right so that they're positive. Okay, so I get x equals 3. Now that is not a solution, but it's part of the solution. It's saying the x value that's going to make them both equal is 3. What's the y value? Right, find y. So here is y, both of these. Which one can we plug it into? Either. It doesn't matter, you'll get the same one because we made them equal. So find y by plugging x into either equation. They will give you the same answer. You could plug them into both to check if you wanted to. 2x plus 1, so y equals 2 times 3 plus 1. So y is 7 and x is 3. So that's the point when we draw the graph where they cross. Okay. So when you're drawing two graphs, it's good to know the point where they cross, and then it makes it sort of easier because you can plot that point and then the intercept. So we're going to do that. So we're going to go back up to the top here because we need to graph them. I'm going to call this one A and this one B, so when I refer to them I can just do it that way. So we need this is called the intersection point. Right, it's the solution. And then if we want the intercepts, intersection is like out on the street. An intersection is where two streets cross. Same thing if you think of these as streets, so the intersection is where they cross. Intercepts are where we it's like a block, so it's like going through that street at that spot. So the intercepts. So let's just write the equation. And I told you last time you have to be able to do the intercepts really quickly without writing too much down. You can write it down, and sometimes I do if it's a little strange. But basically, your model will look like this. So we need 2 points. So if you're finding the intercepts, I would go ahead and write the 2 points with the missing number in them. Okay, I promise you that will eliminate tons of mistakes when I'm marking. Okay, I'll tell you why in a minute. So you need these 2 points. So this says what? X is first. So this is when X is 0. So if we plug 0 in for X, 0 times 2 is 0. Don't even write the 2. So what do we get here? 0 plus 1 is 1. And just put the number right in there. Now this says Y is 0. So 0 equals 2X plus 1. So what do we get? X is negative 1/2. Write the point right in there. Okay, now, so what I said was this. Write the points with the missing spot in it. Put your zeros in, one in the X and one in the Y. Do that. If you don't, this is what happens when you're under stress on a test. You get a Y, and you get an X, and then you go to graph it, and what do you think happens? You plot this as a point, negative 1/2, 1. Can you see yourself doing that? You look back up, you see X is 1/2, Y is 1, and you plot that point. That is not a point on the graph. It's supposed to have the zeros with it, right? So what I say to do to eliminate that happening is write this sort of little skeleton first, then figure out the numbers and put them back in right away. And then you've got 2 points rather than 1. Okay, so there's the intercepts for the first line, and let's do the same thing for B. Write the line. So X is 0 and Y is 0. And then plug it in. So if X is 0, we get Y is 0 minus 2, so negative 2. And if Y is 0, a little harder, but we just have to rearrange it. Two-thirds. So we've got all our points that we need. We've got our intercepts for each line, and we've got the point where they cross. So then we put it all together. So I was teaching my daughter how to draw parabolas last night. And so she's finding all the points, because they're doing order of operation in school. So they're learning order of operation, not parabolas, but order of operation. So I taught her how to plug in numbers in for X into an equation with a squared in it, and then she practices order of operations and then plots all the points. And if it looks like a parabola, it means she got the points right. She did all her order of operations right. She did not want to draw this. She said, do you make your students draw the X and the Y axis? Like, she did not. She wanted me to write that on and to put the little tick marks every time. She could find the points and plot it and draw the parabola, but she did not want to draw the X and Y axis. Why can't you just give it to them, Mom? They will not like drawing that. So, I don't know why, but I'm not giving it to you. You can draw it. Actually, sometimes on the final exam, I do put a little X and Y axis so I can mark quicker, so your answer is all nice and neat on the side, but not always. Okay, so what are we going to do? We're going to go to line 1 and plot these points. If you use a ruler, it's going to be easier because it's going to match up nice. So this is X and this is Y. So you start with 0 and you go up 1. Write your point in there, because when I mark, I'm looking for the points, and all I need to do is look at the graph and see if all the points are right. If they're not right, then I go up and see how did they find that? Is that where they messed up? Okay. So 0, 1, and negative 1/2, that's over here. Don't worry about your line crossing through there, that's fine. So I'm just going to use a... Now, this is what I do when I'm drawing them. I don't know if I have a pencil, but I would use a pencil, not my marker. Okay, so I don't have a pencil with me, but I'm just going to put a little dotted line for now. But you would do it lightly in your pencil line, okay? So, because we have to draw another line on there and we want them to cross in the right place, So you might have to adjust your points a little bit if you didn't use a ruler. So do you see my line is just sort of faint? Because I might have to fix it. So this is line A. And now line B, -2, 0 is the x and -2 is the y. So 0 and down 2. And 2/3. Don't measure out 2/3. Put it in the right area. So 2/3 is less than 1. So it would be about here. Okay. Now, if I draw that line, they almost look parallel, don't they? So I'm going to put the point where they're supposed to cross in, and then you can kind of adjust them a little bit so they're going the right way. If you have graph paper, not a problem. They're going to cross in the right spot. But where you're just drawing a rough sketch, and I don't want to give you graph paper, and I don't want you to do it on graph paper, because when you're doing these as part of a question in another math class, you want to draw them quickly, but sort of accurately, right? So we don't really want it, we want you to be able to fix it so that it's right. What is the intersection point? 3,7. So my one first error is that 3,7 is not on this graph. See it? Can you make yours longer? Maybe you'll have to go up into your writing. All right, scratch that. I need to go up 7. 3, 4, 5, 6, 7. Let that be a lesson. You maybe should look at what your points are first. I just didn't have room to go up 7 here. It'd be off the page, so I'm just going to redraw that quick. So 3, 7 is about here. That's where I want them both to cross. Does that make sense? Okay, so I'm just going to quickly put those points back on. And that looks like it's going to cross that line, or cross that point. They're sort of in the right order. This is 0, 1, and -1/2, 0. Okay, and then our other line, so if you can get them to go through, that would be perfect. So that's line A. And if they don't quite cross, I always just make the point bigger after so that it went through, and then you can label that point, 3, 7. The other one was 0, -2, and 2/3. And I want it to go through that same intersection point. So not a very good ruler, but this is perfect. So my point, I don't know if you can see it there, was slightly off the line where I guess 2/3 was. I'm just going to move it and make it bigger so that and then label them. This is 2/3, 0, and this is 0, -2. Okay? So when I look at your question, I can see everything I asked for right in the graph. So you've got the two lines. Yep, that one's going through the right places. That one is, and they're both crossing at 3, 7. Everything's labeled. This is worth probably 1, 2, 3, 4, 5 points. Half for each of the intercepts, and right? But the other thing is, if you know that they're straight lines and your points are not in a straight line, go back and check your intercepts. You might have done them wrong. Right? Instead of trying to get them to fit, if one of your intercepts is way over here, if you had a point here and here and you're trying to go through that line, that's not going. So there's something wrong. Either this point's wrong or one of the intercepts is wrong. Does that make sense? So go back and judge what you did wrong if you have something. Okay, so substitution, we can set them equal to each other to solve it. The other way we can do substitution is something like this. Okay, so here's the system, and I'm just going to say solve the system. Okay, we're not going to graph this one. So this one, so the first type I said substitution's good for if they're written in slope y-intercept form, you just set them equal to each other. It's also good if you can solve for one of them really easy. Like, say for example, you said here, okay, y is equal to 15 minus x. Do you agree with that? Yeah. So here I rearranged it so that it's in slope y-intercept form really easily. And I could rearrange this one the same way. Do you see it? Really easy to rearrange them to get them in so that the y is by itself. That would be another case where I would probably just do that. So here, what would we say? Y is equal to what? Make it y, not negative y. We just want the y by itself on one side. So I could do it this way. So y is equal to 2x minus 3. And now I've solved them for y quite easily. Right? It didn't involve fractions or anything like that. And then you just set them equal to each other. So the substitution part, 15 minus x equals 2x minus 3. Uh, 15 plus 3 is 18. So x is 6. And then what do we do with the x? Plug it in. Now we've actually solved for y here in both of them, so we can plug it into either one. So we can plug it into 15 minus x is 9. So 6, 9. Or you could plug it in here. It doesn't matter which equation. Y equals 2 times 6 minus 3. 12 minus 3 is also 9, right? You'll get the same answer either way. So 6, 9. And all I asked to do in this question was just solve the system, so we're done. Okay, so I would use substitution if it's sort of easy to solve. And you could solve for x as well. If it was easy to solve for x, then you could set them equal and you'd find y first. Plug it in to find x. So either way is okay. Now elimination, I suggest when it's not as easy to solve for x or y. So elimination So I've written the equations in standard form. And can you just look at it and see that, like, it's not as easy to solve for y because there's not sort of a y by itself, like with just a 1 in front of it. So to solve for y is going to actually involve fractions. You might have to rearrange that and solve for y. Like if I said to, for example, find the slope. Whoops, slope. Like if I want to find the slope of this line, how do I do that? Move this 3x over, and then I don't want the 4 in front, so I divide everything by 4. Everything by 4. Remember, it's just like disguising it. It's still the same equation. You can multiply both sides or divide both sides. So we get y equals minus 3 over 4x minus 1. So what's the slope of this line? Minus 3 over 4. So if we were after the slope, we would have to rearrange it. But it's got a fraction in it. And how do you recognize that right away is if there's a number in front of the y, then it means you're going to have to divide by that number later, and it's probably going to make fractions. If we did that for both of them, we have fractions everywhere. We're setting two equations equal to each other. They've got fractions. Then you have to find common denominators, and elimination, you won't have to do that. Okay? So even if the answer has a fraction in it, it'll be much easier. So elimination. Remember how this works? So you're going to choose to eliminate either the x or the y. So you first need to choose to eliminate, would get rid of, the x or y. So the way I choose, sometimes one's easier than the other. I purposely made it so that it's not that way. So there's nothing easy about this question. I would probably choose the y, and the reason I'm choosing the y is because the signs are different. Okay, so that would be one reason to choose. So I'm going to choose the y. I'll just say choose the y since the signs are opposite. Okay, it's not a rule. You can choose the x, it doesn't matter. Okay, so I'm choosing the y just because the signs are different. Now to eliminate, what you're going to do is add the two equations together. And you want something to disappear. So what we need to do is make a number in front of the y, which we're choosing to eliminate, the same. So I'm just going to write the equation here. And the second one. So my question to you is this. What can I multiply the first equation by and the second equation by so that the number in front of these are the same? So what's the common denominator of 4 and 3? 12. So I want them both to be a 12. Okay? So the common denominator, if they were fractions, so I'm going to multiply this first one by, what can make that a 12? 3. And I'm going to multiply the second equation by 4. They'll have the opposite sign, but the same number in front of them. So, and then the way to do that, so I've written them out with those. So we rewrite the first one. 3 times 3 is 9x. 3 times 4, 12y. And 3 times negative 4, negative 12. And then our second equation, 4 times 2, 4 times negative 3, and 4 times 6. So these are the same two equations, but they're now disguised. They look different, but it's going to work for us because when we add them together, the 12 is going to disappear, because it's plus 12 minus 12. So now we're going to add the two equations. 9 and 8 is 17. These disappear. Write your equal sign. Minus 12 plus 24 is 12. So we've now got a new equation, 17x equals 12. Divide both sides by 17. And we get the x value as 12 over 17. Not nice, but on purpose, because we didn't do one with a fraction yet. And most intersection points are fractions. Most lines don't cross like perfectly on a point, right? It's somewhere in between. How do we find the y value? To either equation. I wouldn't plug it in probably to where you multiplied because they're bigger and you don't have a calculator. Go back to the start. So you can find the y now by plugging it into either equation. Which equation looks nicer? I like the second one better, but it does have a negative in front of the y, so maybe not. I like it better because the numbers are smaller, but these are not bad either. Doesn't matter which one. So say we did 2x minus 3y equals 6. Plug the x in here, so 2 times 12 over 17. See, this is back to the algebra part. How do we solve that? So this is like a 2 over 1. Nothing cancels, so this would be 24 over 17. Isolate the y, so 24 over 17 minus 6 equals 3y. And we need a common denominator. Oh, this is not very nice. So that's like over 1. So what do we need to multiply by? 17. Okay, so 6 times 17 is 60 plus 42. 102. 24 minus 102 is what? 78, thank you. Negative 78. Not a nice question at all. All right, and then what? Cross multiply, like we want the 3 to be on the bottom of this side. So 3 times, yeah, does this have a 3 in it? It does. I'm going to write 17 times 3 because I'm going to show you I always want the reduced answer, right? I just didn't multiply it yet. 78, I said, does that divide by 3? And do you remember the rule for knowing if something divides by 3? Yeah. Add them together, it's 15. Does 15 divide by 3? Yes. Going back over, so 78 does divide by 3. What would it be? 3 and 16? 3, oh yeah, so 26 maybe? Yeah, that works. 3 and 16. So what we've got is, oh, sorry, this is 26. So we have minus 78 over 17 times 3. And 78 is 3 times 26. So here, minus 26 over 17. And that is not, that's like the very first chapter we did. So you can't say that's too hard. That is actually what we did, was reduce fractions, right, in our first chapter, our first section. All right, so this question had a little of everything in here. The solution then is x is 12 over 17, and y is what? Minus 26 over 17? Now really, if you were just being asked to graph and you didn't reduce your fraction, like that would be okay. But in this course, I'm going to ask you to reduce everything just because you need to practice doing that. Not because in calculus you would have to, but because you need to be able to reduce things. So there's the solution. We're not going to graph that. And that's using elimination. And I just made the elimination one a really hard one so it would show everything. But let's do an easier elimination question. Okay, so the first one I made really hard. Here, if you look at your numbers, there's none with opposite signs, so you need to pick whether you're going to eliminate the x or the y first. So to make the x's the same number, you'd have to multiply the first equation by 7 and the second equation by 6. Well, actually minus 6, because you want the second one to be negative, or one of them to be negative. Now what about the y? To make those the same, what would we have to multiply by? The second one, or you could divide the first one by -2, yeah, or you could multiply the second one by -2. So you don't actually need to multiply both. So it would be easier to eliminate the y. So you can just multiply one equation. Now, to make them the same number, you'd have to multiply by 2. But you want them to be the opposite sign. So when you add it, it actually disappears. So -2 instead, because they both have the same sign, so -2. The negative is to make them the opposite sign. Or to make the y to make the y's having opposite signs. So when you add, it disappears. Okay, so we do want them to have the opposite sign, but I only need to multiply the second equation. Now if I do this, I still usually, well, I'm not changing the first equation, so I would usually just rewrite that. And then the second one, multiply by -2. So -2 times 7 is -14. -2 times 2 is -4. -2 times -4 is 8. Watch out for your signs. And now we add them together. These are opposites, so they cancel. 6 minus 14, or 14 minus 6, is negative 8. 8 plus 8. If you had the signs wrong, you might end up with a 0, but 8 plus 8, 16. So you've got an equation, 8x equals 16, negative 8x equals 16. Divide by negative 8, x is negative 2. And then you need to find the y, so you choose either equation to find the y. I like the second one better. Seven times negative 2. So 2y equals negative 4 plus 14. Y equals 5. So the solution okay, so we started with a hard one that you had to multiply both equations by something to make it the same, and you even ended up with a fraction. And the fraction had to be reduced. So a little of everything. The second one worked out nice. Okay, now with any of these, you could find the intercepts, the x and y intercepts, graph them, and show where they cross. Okay, and that's what the homework has. You have to graph them, find the intercepts, and show where they cross. Now, the only other type is if they are parallel, what happens when you try to solve it. Okay, so what would happen is this. Say we had 2x plus 3y equals 6. Whether you solve it either with elimination or substitution. So with elimination, what do we need to multiply here? Let's eliminate the x, because we've not done that before. Okay. So if we wanted the x's to be the same but opposite sign, what would we do? Multiply the first one by negative 2. That will make it a negative 4. So negative 4x minus 6y equals minus 12. And then our second equation, add them together. What happens? Both the x and y are eliminated. Okay, so this cancels and this cancels, which means we have nothing on this side, 0. And what do we have on this side? Negative 11. 0 is not equal to negative 11. We have no x or y left. And when that happens, this means no solution. And no solution happens when the lines are parallel, right? They didn't cross. So no solution, which means the lines are parallel.
Did you rearrange the original question? Both of them would give you a 2 over 3 slope.
Both would have a slope of negative 2/3.
Yeah.
Yeah. So this one is already in, and you might notice before you try to solve it that they're parallel. Maybe here you didn't notice they were parallel. That's harder to notice unless you rearrange them and see what the slope is. But here, do you see the slope is both 2? So they're parallel before you start. But say you didn't notice and you set them equal to each other. Same thing happens, right? You end up with 0 equals a number because the two x's cancel. Okay? Now what if they were the same equation? What's going to happen? So this is no solution. Therefore, the lines are parallel. Perpendicular is not important because that has one solution. Perpendicular lines have different slopes, so they do cross at one point. So what if they were the same two equations, but you didn't notice? So I just wrote one equation and then I multiplied it by 3. So it's actually the same two equations. What happens if you go to solve these? So what would we do? Multiply the top one by -3. And then what happens is we get -3x plus 3y equals -6. 3x minus 3y equals 6. That's the second one. What happens when we add them now? 0 equals 0. That's true. 0 is equal to 0. And when that happens, it means both equations were the same. This is okay. It doesn't mean no solution. It actually means that every point is a solution. So that happens, you can actually go back to the start and say, are those the same lines? Right, 0 equals 0, and you say, oh yeah, this is just multiplied by 3. I could disguise it a little bit more by doing something like this. Say I said y equals 3 over 2x plus 6. And then I said that 3x minus 2y equals -12. These are the same two equations, but I rearranged them. So you don't maybe notice that they're the same two equations just by looking at it. But what if you did get something like this? One is in slope y-intercept form and one is not. You don't actually need to put both in the same form. I'm glad I wrote this because this is a really good. I would not put them. You can put them both in the same form. That is one way, whichever way you want. So you could solve for y here. These are the same two equations, so I'll just write it quickly, a different example. Okay, that they're not the same two equations. So if we were solving this, I would use substitution in a little bit different way. The y is already solved. I would put this y right in here instead of that y. So you put one equation into the other. So that's another option. So instead of the y, so here I rewrote this equation. I took out the y. You see it? Just the 3's there. And y is equal to 2x plus 1. Plug that in and you'll be able to solve for x. Three over 8 fraction, not nice, but we can solve for y easily by plugging it into the first one, because that's already solved for y. Let's do it quick because we're out of time. So 3 over 4 plus 1, which is 4 over 4. Okay, and you can go back and check because I just did that quick, but you can just write it down and you can go back and check. So we're done all of 2.1, 2.2, 2.3, so you can try all the homework. And they're sort of mixed together. You have to graph them in each section and so on.